So first of all, thank you very much for coming here today. I have the pleasure of having with me Paul. I will let Paul introduce himself because I don't want to mess up. Most of you, I guess, you know him. But the idea that we have today, after Paul's introduction, is to talk to you about cloud security and some of the challenges that companies are facing, how to drive efficiency, and a little bit of real experience. Instead of a very commercial speech, the idea is to have something real, something with content. A very technical session. We will touch some concepts, and we hope you enjoy it.
Thank you for having me here, Carlos. I'm Paul Jane. I work as a cloud security architect in Schneider Electric for the last 2 years and in charge of security cloud architecture globally across all the cloud service providers.
Cool. So to be very, when we were preparing the presentation, I didn't want to scare Paul, but the first question is something that I was like, as we say in Español, a cuchillo, is just to start on a high level. So Paul, can you describe the main security challenges that you face before implementing a cloud-native security solution, and how has this solution, if ever, addressed those challenges?
Well, taking into consideration that Schneider Electric is kind of a big corporate company, problems escalate exponentially. So since we are a cloud-agnostic company, as many others, there's the need to centralize everything into a single point. So while analyzing the market, we did an extensive research looking for not a perfect match product, but maybe the one that satisfies the highest percentage of our security requirements. So we did some kind of 3 phases approach. We were focused first of all in cloud data security. By performing malware analysis, we ensure that there's no virus or malware or infected files in any of our cloud storage buckets. Then on second phase, we have the cloud security posture management, where let's say we wanted to improve our incident response mechanism and procedures. So the main pain point there, it was, let's say, drawing the path that an attacker will follow. Gathering all that information is a very time-consuming and tedious process.
So the attack path basically was something that you really were looking to improve?
Yes, having the quick representation with all the information in a centralized point. So
before having a solution like that, how were you tackling that issue? I guess, as you said, it involved the IR team.
Yes, it's basically a lot of manual procedures, like a lot of manual tasks that now can be fully automated or mostly fully automated.
So that's nice that you were using not the acronyms. Last year with Alberto, we were also discussing how vendors make your life a bit complex by using extensive acronyms. In this case, Paul was mentioning Cloud Security Posture Management, CSPM, Cloud Data Security, CDS, Cloud Workload Security, CWS. Sorry on the name of the vendor for flooding you with so many acronyms. That's why today, even we will have to use some of those. We will try to avoid them as much as we can. And it's kind of interesting, Paul, that how you structure this approach based on these 3 pillars. That we will elaborate a bit deeper.
The last one, as you mentioned, is the cloud workload security. Our main focus is to be on runtime environment. Even we have a lot of mechanisms and security controls in our software development lifecycle. We just wanted to ensure that nothing bad goes to production or even a development environment.
So I guess you also have a kind of, I'm pretty sure you, as you said, Schneider is a huge company. You have many mechanisms, even before the runtime. I don't know if you want to elaborate a bit on those mechanisms.
Well, basically from the first step when a developer is developing locally, it can be many controls. Then we have the CI/CD pipeline. The code is analyzed on the repository. Pipelines can have some steps to ensure that nothing bad is in the code. Then that code is built upload it into an image on a registry. The registry can be also scanned. And the last phase, let's say, is the runtime environment that is the one I'm most worried about most of the time. So we needed to ensure that we need to detect anomalous behaviors or suspicious activity on runtime environment inside the cluster.
This is something that you are doing also in development, in staging, and in production, or?
We're trying. We're trying. It's complex, such a big company, you have many teams, different environments, there's a lot of exceptions, so yeah, sometimes it's not as easy as it sounds or as you want it.
You follow some frameworks and things like that, I guess you...
Yes, there are a couple of main driving frameworks, but yeah, we're just trying to pick the best of each security framework and adapt to our security requirements.
Cool. I guess was quite an honest and real answer. With that being said, let's go to the next one, and we will change because we are very focused on the defense side. Let's talk a bit about the offense side, because at Schneider you have the arsenal ready with many toys, as Alberto and your colleagues say. And I would like to understand how, if ever, you are leveraging offensive security to apply that to cloud environments.
Yes. Yes.
And how do you think, do you also have a vulnerability management process because you need to detect in order, or you are focused on the red team? How can we relate those?
Well, during the proof of concept, for instance, we discovered some vulnerabilities that we were able to rapidly address and communicate the teams, so they were able to fix that as soon as possible. But yeah, as I mentioned, we wanted to optimize our incident response mechanism and procedures. So we started, how explain this? When our incident response team detects the vulnerability, they can check on the tools if it's exploitable or not. Once they can double check that it's exploitable, then they can leverage on all the information provided by the tool to contact the asset owner or the team responsible for that technological stack and tell them to fix that as soon as possible.
So I see two challenges here for the SOC or for the IR, and then I would like you to elaborate a bit. Let me explain. The first one is the exploitation phase. Do you have like a red team in place? How do they exploit the vulnerability? If that's something that you can...
Well, I cannot reveal many details about that department because it's also not my department. But yeah, they have some specific procedures for checking every technological stack or even account before reaching production. There's a lot of testing and security tests done.
Nice. And the second one is, okay, once your red team has confirmed that the vulnerability is exploitable, assign a criticality, how's the process of patching? How do you educate your teams, your cloud teams, to say, hey, we have to, you just tell them, hey, read the cloud documentation, this is something that you have to fix?
No, the tool also provides some tools provide remediation steps. That increases dramatically the speed of remediation. So this is the vulnerability, here's how to fix it, so you can just rely on that information and pass it to the developer
so the remediation
teams.
Steps, you provide them with the remediation steps that they need to follow. And then with their knowledge, they understand how can it be impacted.
Yeah, most of the times, they come to us and, hey, we need to set a meeting to this, and we discuss a little bit further.
You have like the playbook in which you maybe approve if...
Yes, there are several playbooks defined for each kind of incident and how its criticality. The SLAs and the time we have to
remediate, the time to remediate. That's nice. So how has your team improved the efficiency after the implementation of one of these solutions? How was the process? What are the lessons learned? What's the key word for you, if you have to say just one or two words about?
Observability and visibility. We gain a lot. I mean, when you implement tools that help you gain some visibility in the pillars we were mentioning before, CDS, CSPM, CWS, and so on, you start to gain some level of, let's say, security maturity across all the cloud security providers. So when you reach, or you want to reach that specific level. And for doing that, you need to rely on those principles, basically.
So you follow the cloud security providers maturity levels in order to elaborate yours?
For
or?
most of the cloud security providers, and then we try to unify because each service provider has its own framework, you know.
And the naming as well, maybe. In
Naming
some cases
conventions, yeah.
Yeah. Cool. And how do you report that? Because you said multi-cloud, we are talking about probably hundreds or thousands or millions of assets distributed across many or some cloud providers. How do you report that data? Because I guess that's the tricky point, maybe. That's something that it shouldn't be easy.
Yeah, here's a funny one. Before knowing that there were some products that were doing this, we had the need. So we started developing our own cloud asset inventory software based on the raw data that the cloud service provider provides us. So now we can compare data. We can have different metrics. We can compare. We can detect if we have a data drift or something like that, if the data is accurate enough.
So you said drift is the DevOps team drifting with the cars?
No,
in the parking lot?
I was referring drifting, data drift. For instance, if one tool says that you have, I don't know, 1,000 compute resources, and the other tool tells 998, where are those two missing?
Okay,
you cannot miss any.
No, that's a great point. Otherwise, the attackers will find those two probably,
For sure.
and we will be in trouble. That's nice. So how the deployment of one of these solutions enhance your capabilities in managing and visualizing the resource? It's a bit linked to the other one, because you were mentioning about your own tool for the asset inventory. Does that tool, or there is a tool in the market that help you addressing that issue? Because I guess the tricky point is somehow you detect those things, and how do you communicate them? And the way that you communicate, you said about playbooks and so on, but how's the process of identifying who's the owner, reporting them, and how do you?
We rely on the tags, basically, that you can assign to any cloud resource. So those tags are written and parsed by most of the CSPM tools. So you can have all that information on the screen, and you can even give access to the tool to some account owner or group of developers, so they can just enter that control plane or website, and they can see all the information right there. So
this is from the SOC, they report to each owner?
Yeah.
And do you track them through a ticketing system, I guess, or?
Yeah, there's also internal ticketing systems, different criticalities queues, and so on.
Cool, that's nice. So what specific features of a CNS solution are the most beneficial to your environment? I don't like to say that there are good or bad solutions. I say there are solutions that adapt in a better way or in a worse way to specific environments. But for you, what are your key takeaways on the functionalities that you really say, hey, this is really beneficial for me?
I would highlight, I mean, from the classical cloud security posture management tools to cloud data security, but I will say that you need to cover compute resource, networking, identity management, and storage. Those are the 4 pillars in any cloud environment you need to cover. Sorry, can you repeat the last question?
No, I mean, I was looking for your key takeaways on observability, on visibility. What are the features that you find most beneficial in those kind of solution? And a bit of why. Something that, of course, things that you are missing, things that...
Well, worth to mention, I will add on top of that registry scanning. I mean, the ability to integrate with different registries. It doesn't matter the tool you're using, but that tool must be capable of connecting with different CI/CD tools, registries, so you can scan the software, the pipeline, and the container images, wherever they reside. And I don't know, the why, because Kubernetes is exploding, already exploded the last 5-10 years, so it's everywhere and exponentially growing. All the services are being migrated to Kubernetes, so we need to ensure there's no anomalous behaviors.
So when we talk about Kubernetes, I guess, I'm trying to go back to the runtime protection that you were mentioning before, even you do registry scans and things like that. What's the feature that you appreciate the most? Because in terms of DevOps, I know they are very sensitive to resource consumption. to dependencies and things like that, what's for you something that you really appreciate in a runtime solution, running specifically in
Yeah, the capability of detecting anomalous behaviors, basically, because that's something that not all the tools can have. You cannot work at eBPF level at some point, so these tools only, I don't know, can detect just immutability of the container if you install a package or not, if the container mutates or changes, but some of them are not able to deep dive into specific details in order to detect advanced persistent threats.
That's also a great point, the mutability of the containers. Even there are some mechanisms in place. Having a runtime protection solution, it's helping you probably to give immutability to these containers. The question that I would like to ask is, how does DevOps coexist with a solution which is somehow managing containers to make them immutable? Because you were saying we are trying to do that in development, in staging, and even in production. In production, I understand it can be easier because, of course, we don't touch production, on Fridays especially. But how do you... Can you sleep well at night, or your ears are beeping?
Are beeping a little bit, but I think it's a matter of mentality. Over time has been changed from my point of view, and people are starting to follow best practices in every path. Like, it doesn't matter if it's cloud, Kubernetes, software development. People are starting. I think you just need to conscientiate everyone of the importance.
So you are educating probably on
Yes, training, constantly training everyone, all the teams.
What's the biggest challenges that you face in those trainings? What do they complain? I would like to...
No, I mean, I don't do the trainings.
Okay.
We make a huge effort on train everyone so they can be specialists in specific areas.
Okay. Nice. So last one, Paul, what are you said two words before that were observability and visibility. Those are your key takeaways, but if you have to comment a bit on the implementation of a solution like that, given the challenges that you were facing before, what was your biggest challenge in the implementation, given the size that you were mentioning? And what's your, in addition to visibility and observability, what are your key takeaways or best practices? Something that you really, or maybe something negative about?
Well, maybe worth to mention, one of the features, like how it's called, the secret scanning, in order to detect secrets, tokens, and API keys on the source code. Maybe it will need to be a little bit more flexible to deep dive a little bit more, but I'm pretty sure that will be optimized.
In analyzing the content, maybe too.
Yeah, because during some tests, we were able, let's say, to trick those tools in order to bypass some of the controls with the Cyber Arsenal team and all those guys. So yeah, we make a huge effort trying to trick all the products to test them at their maximum, let's say.
So on the implementation side, was it very hard, given the size and complexity?
It depends, but basically, since it's kind of a, let's call it, read-only tool, it just connects to your environment, gather all the data, and push it into a web console so you can analyze, filter, and select which issues and vulnerabilities you want to see, you want to select, or you want to be noticed for. That's
great. I think we covered all the questions that we prepared. It was great having you, Paul. I don't know if we want to answer some question. If someone wants to say something, there will be things that maybe we cannot discuss, but we are open in case someone wants to know something. No questions? Okay, so thank you very much for attending. We give you 10 extra minutes. With that being said, thank you so much. We hope you enjoyed, and we hope that there was good things. Thanks, Paul, for being with us today.
Thanks, Carlos.
And it was a pleasure.
Same.
Cool.